if you join the Bitcoin DevKit Discord server, you'll find there's another team there. Actually, they're from India as well, who is trying to use Flutter for their app. Or I mean, they are using Flutter for their app, but now they're trying to see if they can like use the Bitcoin DevKit for the app. And so that's sort of one of the frontiers, because you'd have to create the language bindings for Dart, right, which is the language Flutter uses. And so I know that that's been discussed a lot in the Discord servers, like Dart being potentially one of the next languages to create language bindings for. And Dart is interoperable with C, from what I understand. So it's maybe an easier language binding than the one we're working on right now, which is like the JVM and the Android runtime. So that'll be cool. As soon as, as soon as as it works. And I don't know if you if you've looked into it, but the Flutter Dart library for Bitcoin is just like, it's a bit sad right now. There's not a lot of stuff implemented. It doesn't get a lot of like love. I know the maintainers, or the last time I looked at it, it hadn't been touched in like 6 months. So it's also like, it's the kind of thing that's for when you're dealing with like Bitcoin stuff, right? You want to be, anything that's security critical, you want to be really, really careful there. Like libraries are not touched, not well maintained. Gosh, that's harsh. You don't want to play with that too much. Like you want to, test with it, have testnet things, right? Testnet projects are super cool. You can learn about them. But if you're trying to implement like real money, like things people will be using for money, it's really, you want to play with a library that is well maintained, is firing, lots of guys, lots of people, I mean, lots of like eyes on the code, and the latest stuff is being worked on. And, so, and Bitcoin is really iterating really, really quickly. So there's a lot of stuff to keep on top of. So for example, at this point, any library that hasn't been updated in a year is really out of date in terms of like PSBTs, output descriptors, all of that stuff is kind of like, if you haven't updated your library, you're late to the game at this point. So you need to really, people, if you want to use like the latest stuff, it's really cool. And that's part of the reason why Rust with the language bindings is offering a really good trade-off there. Because if we figure out, once we figure out all the memory management and the sort of like bridging to other languages, the complexity, the work has been front loaded, right? All that complexity is hiding behind those language bindings, and then all eyes on the Rust library. And then that becomes like the one true library that you can just like rely on. And right now, a lot of like the latest development in the Bitcoin ecosystem are developed on those Rust. Like there's a whole ecosystem of Rust libraries for Bitcoin that's very firing. Like this is where a lot of the things are happening. And so you sort of ensure that you're always on the latest. And that's what the BDK is using as well, right? The BDK is not just built from scratch. It's relying on those lower sort of like foundational blocks of code that are built in other libraries that are part of this Rust ecosystem. So it's a really good foundation, in other words. The rapid development of Flutter packages might slow down the Bitcoin development library. Is this the case? I think that what we'd like to do is to have these language bindings ready for Dart in a way that you would just pull the latest library with the language bindings, and it would just like work. And so the speed at which like Flutter is doing their thing should not impact too much, as long as Dart doesn't change too much. But there's a big difference there between Flutter and Dart. And I think that for the Bitcoin DevKit purposes, it would be really, really the Dart part. So if that doesn't move too much, right? What's Dart right now? It's like 1.4 or something. If that doesn't move too much, then the library should be good. And then its integration into Flutter is then that'll be up to you, or to whatever develops. Maybe if somebody develops like an outer layer or sort of something on top there, maybe that could be breaking all the time. That's possible. Yeah. All right, let's move on. So task number 7, we want to implement the send functionality. So we want to send Bitcoin from our wallet. Okay, cool. The send functionality basically breaks down into 4 parts. One, and this is all happening with the Bitcoin Dev Kit, so it's pretty easy. One, we create this transaction. So like we talked about yesterday, these PSBTs can be built without being signed, right? They can be just like the metadata, all the information about the transaction can be sort of structured without the transaction, the PSBT being ready for broadcast. So that's what we're going to do. The first step is to create this transaction. The second step is to sign it. And in our wallet, what we're doing is we only create transactions that we can sign completely. So we don't create multi-sig transactions that we can sign a part of it and somebody else can sign another part. We're not doing here. We're not doing this here, although we could, and that's maybe something you want to explore if you're interested in like building something else for the rest of the week. Like multi-sig setups are super cool, although it's a bit more advanced, I would say, but it's a really cool feature that can totally be done with the Bitcoin Dev Kit. We want to sign this transaction. Then from that, we want to extract the raw transaction, because the PSBTs are this sort of data format. They're not what you broadcast to the network is not an actual PSBT, right? The PSBT is a bunch of fields. You can think of it almost as a JSON object. It's not a JSON object, but like, fields and, data structures in there. So from that PSBT, once it's finalized, we want to extract it into a transaction that's ready for broadcast. And then last part is we want to broadcast it. And note that it's important that those two are separated. Those two tasks are separated because it's possible that we want to build this transaction without access to the network. You can imagine a device that would have no connection to the internet. So you would just give it the pieces to sign, and it could sign it, then extract it, and then it would be ready for broadcast, but it wouldn't be broadcastable by the device because you don't want that device to touch the internet, for example. And then from there, you might put that transaction that's ready for broadcast, you could put it into onto another device and then just broadcast it from there. Or you could send it, right? You could send it in an encrypted way through, text message or email, encrypted email, whatever, to somebody across the world, and then they could broadcast it from there. So the broadcast location would be different than where it was actually created, this type of thing. So those are very separate ideas. The idea of like building it, signing it, and then broadcasting it, 3 very separate tasks. And we can do all of those with the Bitcoin Dev Kit. So we're going to get into the send fragment, sorry. Send fragment here. Sweet. Oh, I was like, that's neat. Very small. No, it's because I'm not on the right thing. Okay. So my send fragment is now much bigger. And most of what matters is happening in this broadcast transaction. So the to broadcast the send, to broadcast confirmation is a button that we're going to have a look at. This is the UI for my fragment, right? This part here on the left. And so I have text views and edit text. So edit text views are the ones where you can actually enter things. And then the text views are the ones where you can't actually modify the text. So like things like send to and amount are text views, and then the address and the number of Satoshis you want to send, those are edit text. So we have those, and then there's a button called broadcast transaction. And that broadcast transaction, we want, that's where a lot of the complexity is hidden. Just gonna close those, make sure we're starting pretty much fresh. Send fragment. Okay. And when we click that button, what we're going to create is a broadcast transaction dialog. And these broadcast transaction dialogues, these little dialogues, I'll show you what they look like. Is this going to work? No. sorry, actually, we're going to have to rebuild. Dialogs are what you see here on the GIF. Once I put in the right amounts, this right there is a dialogue in Android. It's called a dialogue. And in web development, you'd call that a, gosh, I forget the word now. Let me know in the chat if you remember. What's the word for that? Anyway, that thing that appears, that sort of like sits on top of your screen. So this dialog builder, what we're using is we're creating this value, broadcast transaction dialog, and we're using an Android class called the material alert dialog builder. And there you go. Somebody's got the answer here. No, not a toast. Good one. Not a toast is not a modal. Thank you. Thank you. Modal is the word I had in mind. So the equivalent of a web modal here, we're calling it a dialog. So I'm creating this dialog here, and it's a builder. Again, another design pattern. If you're not familiar with builders, look them up. But the idea is to create this little thing piece by piece. So I'm creating this material alert dialog builder, and we give it a title and a message and different things to do if the person presses the positive button or the negative button. That's all. And if you press the positive button, you'll find that we're going to run this broadcast transaction method. And the message will be this build confirm transaction message. So yeah. So the build confirm transaction message is basically just saying, I'm going to go into these text views and I'm going to pull the string out of there and say, hey, is this really the address you want to send to? And is this really the amount you want to send? That's kind of what we're doing. And we're putting that in the logs and whatnot. And so, yeah, here, so the heart of this whole thing, I'm going to try something here. If I press broadcast transaction, this is what we're trying to build. And then if I press broadcast, there's a set on click listener on this. And what it's going to do, what it's going to fire, right? It's my line 53 is this function here, 71, broadcast transaction. And this is the gist of this whole task, is this method there, broadcast transaction. And it can, errors can happen. You can have wrong inputs. There's different things. You might not be connected to the internet, that kind of stuff. And so we're doing a try catch statement. So we're trying to build a transaction. And if it doesn't work, then we return a snack bar. And I'll show you later what a snack bar looks like and what it does. But let's focus on the try part of it first. We need to build the pieces for that transaction to happen, the pieces of data that are required for the transaction to happen. And the first part of it is the fee rate. The fee rate is a great example of something you could implement. So in the wallet, if you want to keep working on this for the rest of the week and try to implement different things, this would be a great example of something you could implement. See, notice that I'm putting this, it's hard coded in it. The user doesn't get to choose the fee rate right now. It's on testnet, so the transaction will go through no matter what, but we're setting the fee rate to be 1 Satoshi per version byte. And so, but that could be chosen by the user, obviously. And so we have a fee rate, an address that we're sending to. And this is, again, just using the bindings and then finding that text view. I have an ID for it, send to address and send them out. And I just pull it and I trim it, transform it into a string, trim it, whatnot, and then an address and amount. And this is a list of pairs. Pairs are Kotlin type. and it's a generic type. So it's, in this case, it's a pair of a string and a string. So we want to have an address that we send to and an amount. And for us right now, the wallet only allows for one addressee, right? One address that you send to. But this could be another thing you could work on. It's like you could have the option to add another wallet you want to send to, another address, right? Because any given transaction can send to as many UTXOs as you want. So you could implement like multiple, but right now there's only one. And once we have these 4 pieces of data, these 4 things, we're going to go and talk to the wallet class, and we're going to create this transaction. So it's, what's happening is in this here. This is the important part. Wallet.create transaction. We give it the fee rate, address amount, and then, you know, some other stuff you can look up in the BDK JNI, but that's the gist of it. And that thing, the wallet create transaction method, returns a create transaction response to us. And I'm storing this in the transaction details value. And then that transaction details has, we'll print it to logcat so you can see what it contains, but it has a lot of stuff. But one of the things it has is the PSBT. So when I need to sign it, I'm going to say, I want to sign response type, and I'm just going to go to this wallet again and ask it to sign it. And I just need to give it a PSBT. So we're passing this PSBT to the wallet sign method, and it returns a sign response. And that sign response contains the raw transaction. And I'm extracting it here on line 82. I'm pulling it out, and I broadcast it. That's it, line 83. And so this is a whole, like, we're doing all the steps that we talked about, right? Creating the transaction, pulling the PSBT out of it, extracting it into, signing it, extracting it into a broadcastable format, and then broadcasting it. So those 4 lines are doing all of that. And at any point, there might be errors that are being thrown. If that happens, we're going to flow into the catch statement here. And this is just going to log it to the logcat, and we're going to fire up a snag bar saying, hey, you made a mistake. You know, this particular thing is not working. And if not, it will succeed, and we're going to fire up a snag bar with a success snag bar. So the toasts. So somebody talked about toasts earlier. Android used to have these things called toasts. They still have them. You would recognize them. They're at the bottom of your screen, and they sort of like appear, and they're like rounded, cornered thing. And those are being slowly deprecated in favor of snag bars more and more. So people want, Android recommends, Google recommends that you use snag bars instead. And I'll show you what's inside my snag bar utility here. It's pretty simple, but we want to, here, what I'm trying to do is create these snag bars so they appear to the user, right? You can know if you've made a mistake, or if there's an error, or if your transaction has succeeded. And I have 2 different backgrounds for them, and they're defined in these sections here, r.drawable.background snag bar success. So if you go in my drawables folder, you'll find the background snag bar success is this little blue, and the error is the red. So this will set the background for our snag bar, and then we're setting the color of the text for it, and then sort of like how the animation, how the snag bar will appear, how long it stays, that kind of stuff. And once we have that, we just fire it up, and this is what line 27 does. We show that snag bar. So when I use that little utility, I'm just calling show snag bar, and I want to be given a view, which this is just part of the context. We just give the view, and then a level. So it's either an error or success. It's this enum at the bottom there. So I need to either choose whether it was an error or success, and then a message that I want to pass. And that will print the message to the screen, basically, into a snag bar. And so you can see that method being called here, that function being called here. I'm passing the view, a level success or a level of error here, and then a message. So let's try this up. Let's try this. And I don't know if, yeah, okay. So if I try to send and I broadcast this, right, this should throw an error, right? We're not, the address is invalid. And this at the bottom is my snack bar. And it disappears. Time's flying, so anybody has a testnet address they want to post in the chat? First one to post a testnet address, I'm going to send some Satoshis to them. Or we're going to try. Bam! Somebody's quick. There you go. So I'm going to go to the send. Oh, I'm not sure. So I copied it, but I don't know how to paste it. I wonder if turn on clipboard maybe. Ah, sorry, folks. I don't know how I can copy paste this into my emulator. I don't work with the emulator as much as I work with my phone. Can we increase the time of the error message? Yes. Absolutely. So the error message, the time, just to be clear, the time is defined. Snack bars. The time is defined here. Snack bar make, snack bar length long. But you can actually, it's an integer, so you can give it it's in milliseconds, so you could give it like, you know, a full like 10 seconds if you wanted to, and it would stay on the screen. Yeah. You need to have it the emulator keyboard. Okay. Oh yeah, there you go. Cheers. Thank you. And we're gonna send you. No. We're gonna send you 21,000 Satoshis, my friend. And notice that the fees are set, so I'm not letting the user choose that. And if I try to broadcast this transaction, is this the right one? We're just going to check 6W. Yeah, that's right. And I'm going to broadcast this. Snack bar transaction was broadcast successfully. Harsh, let me know if you receive it. And if I look at my transaction history, nothing's going on because we haven't implemented that. But if I sync, I should see, yeah. Nice. Epic. All right, so let's see if you can send them to someone else in the group, or send like half of that to somebody else in the group. So is that good for everyone? Am I making sense? Are we like making progress here? It's looking good. You're happy with this? Utilities, the snack bar, snack bars. Now that you know how they work, you could use them. This is something you could definitely use them liberally throughout the app, right? There's a lot of like feedback that needs to be given to the user when things are happening, when you're trying to connect to the network, there's a ton of actions that right now we're sort of logging in the logcat. So you would know that they happen if you've got your emulator or your phone connected to your machine, but otherwise like the user is really unaware of what's happening. So we want to be using those snag bars a bit more than we're using them right now if we wanted to provide like a good user experience. So there's definitely a lot of things we could do with the snag bars there. A lot of messages we could send. Nice. Keep them coming. I can see you're sending those Satoshis around. If there aren't any more questions on this task, I want to get into the transaction history task.